This is part 3 of question number 6. So let's start reading the question. Says the car descends the same hill with the engine of the car working at a constant rate of 20 kilowatts. The resistance is not constant. The initial speed of the car is 20 meters per second, and then 8 seconds later, the car has speed of 24 meters per second and has moved 176 meters down the same hill. We have to use an energy method to find the total work done against resistance during the 8 seconds. So first let's write down the information that they've given us. So they've given us the power of the car, which is 20,000 kilowatts. 20 kilowatts, which will be equal to 20,000 watts. But in this case, you will notice that since it is over these 8 seconds, in that matter, this will be equal to the average power. Other than that, they've given us the initial speed of the car, which is 20 meters per second. We will write down that as u. And they've given us the final speed of the car, which is 24. And they've given us the total distance traveled, which is 176 meters. And they've also given us the total time, which is 8 seconds. Now, if you notice that the formula for average power is work done over time. And since we have the total power as well as the time, which is 8 seconds, we can find out the total work done. So that means that 20,000 is equals to the work done divided by 8, which is total time. That makes the work done equal to 20,000 times 8, which is 160,000. So now comes the main part of the question. What you have to realize is that the formula for total work done is always equal to the change in kinetic energy plus the change in potential energy plus the work done against friction. So in this question, we have to find out this component, which is the work done against friction, and we have the total work done, which means that if we find out the change in kinetic energy and the change in potential energy, we can then manipulate this equation and find out this work done against the resistive force. So let's do that. So the change in kinetic energy has a formula which is half times the mass times the final velocity squared minus the initial velocity squared. So if we notice, we already have these values, and since we're carrying the mass mentioned in the part 1 and part 2, that will mean that this is equal to half times 1250, which is the mass, multiplied by 24 squared minus 20 squared, and that is equals to 110,000 joules, since that is the unit for power. So moving forward, we have to find out now the change in potential energy. And the formula for that is the mass multiplied by the force of gravity multiplied by the change in height. So now you'll be wondering that how will we find out this change in sine theta was equals to 0.1. Now how we can use this information is that suppose that this is the hill. This is the angle of theta at which it is inclined. So if we draw a line over here, this becomes a triangle, and sine theta is always the perpendicular over the hypotenuse. And since the car is traveling downwards, the hypotenuse will be equal to 176 meters, which is the total distance traveled. And this vertical length is the change in height. So it is going from this point over here to this point over here, at which the height is equal to 0. So when we use the sine theta formula, that means that sine theta, which is 0.1, must be equal to the change in height, which is the perpendicular, over the hypotenuse, which is 176. This makes the change in height is equal to 17.6. But this will be negative 17.6. That is the case because the car is moving downward since it is descending the hill. That means there is a negative change in height. which is negative 17.6. That means the change potential energy is equals to the mass, which is 1250, multiplied by the gravity, which is 10, multiplied by negative 17.6. That is equal to negative 220,000. So now that we have the change in kinetic energy as well as the change in potential energy, we can now use these two values in the work done formula that we did over here. So the final step. So that means 160,000, which is the total work done, is equals to 110,000 minus 220,000 plus the work done against friction. So that means that 160,000 minus 110,000 plus 220,000 must be equals to the work done against friction. And if you do the calculations, we'll find out that this is equals to 270,000. So now we have the total work done against the resistive force, which is the work done against friction.